Hello everyone, and welcome to the Waveshare ESP-IDF Getting Started tutorial. In the previous lesson, we set up the ESP-IDF development environment. If you haven't done that yet, we recommend reviewing the first lesson and making sure your environment is ready before continuing. In this lesson, we will run two official examples, Hello World and Blink, to get familiar with the complete ESP-IDF development workflow from creating a project, configuring the chip, building the firmware, flashing the device, to monitoring the serial output. By the end of this lesson, you will have a clear picture of how to develop with ESP-IDF in VS Code. Before hands-on practice, let's look at the general ESP-IDF development workflow from a high level. The process consists of 5 main stages. Create project. First, you need a project framework that complies with ESP-IDF specifications. You can start from scratch or use an official example as a template. Configure project. Set up the project to match your hardware and the features you need, such as selecting the target chip model, setting Wi-Fi parameters, and adjusting the log level. The configuration results are written to the SDK config file in the project root directory, which the build system reads when it builds your project. Build project. Compile and link the project source code and its dependent components together to generate a binary firmware file that can be flashed. Flash project. Write the firmware generated in the previous step into the ESP32 chip's flash memory. Serial monitor. After flashing is complete, the chip automatically restarts and runs the written firmware. You can use a serial monitor to view the log output from the chip in real time and verify that the program behaves as expected. In practice, the steps you'll run most frequently are build, flash, and monitor. You'll complete the entire project by continuously modifying the code and verifying functionality. Now, let's get started with the most basic Hello World example. This program will print Hello World and basic device information over serial, then count down and restart. Open VS Code. In the left activity bar, find and click the ESP-IDF icon to launch the ESP-IDF Explorer panel. In the Advanced tab, click New Project Wizard. In the pop-up tab at the top, select the ESP-IDF version you want to use. Pick the one you installed in the previous lesson. Expand the ESP-IDF Examples category. This lists all the official ESP-IDF examples, covering everything from basic GPIO operations to complex network applications. It's an incredibly useful reference. Find the Get Started category and select Hello World. Then click Create Project button. Next, set the project name, storage location, and related options. Note that to avoid potential build issues, it is recommended that the project path does not contain spaces or special characters, and the path should not be too long either. Settings related to the development board can also be modified after the project is created. After completing the settings, click Create Project. The ESP-IDF extension will automatically copy the example code to the specified location and display Project has been created. Click Open Project to open the example project. After opening the project, let's briefly understand the ESP-IDF project structure. You don't need to memorize this, just get a general sense of it. Main folder. This is the default main component of an ESP-IDF project, which stores the core source code of the project. Hello World main.c under the main directory, the program entry file. You can see an app main function in it. The entry point for a standard C program is the main function. But in ESP-IDF, the application entry is replaced by app main, which is called by the framework. cmakelists.txt. There is one such file in the project root directory and under each component directory. They tell the build system how to organize and compile the code. At the beginner stage, we don't need to modify them. After understanding the project structure, let's go through the entire process of building, flashing, and monitoring. In the bottom status bar of VS Code, the ESP-IDF extension provides an integrated toolbar covering common operations. First, select the flashing method. Choose the UART interface. Second, select the serial port. Connect the ESP32 development board to the computer via USB. Then, click the port number on the status bar and pick your board's port from the list. If you're unsure which one it is, unplug and replug the board once. The newly appearing port is the one. Third, set the target chip. Click this button and select the chip model, ensuring it exactly matches the chip on the development board. For example, the ESP32S30 corresponds to the ESP32S3. After selecting the target, ESP-IDF will perform initial configuration in the background and generate the SDK config configuration file in the project root directory. This will take a few moments. Fourth, build the project. Click the Build Project icon. ESP-IDF will start compiling the entire project and generate the binary firmware. The first build takes a long time because it compiles many low-level components. This is normal. After the build is complete, you can see that a build folder has appeared in the File Explorer on the left. It contains all the intermediate build files as well as the final generated firmware. Fifth, flash the project. Click the Flash Project icon to write the firmware you just built to the board's flash memory. Finally, monitor the device. After flashing is complete, click the Monitor Device icon to start the IDF monitor. The serial output from the board will now be displayed in the terminal. You can see it prints "Hello World" device information, then enters a countdown and automatically restarts. To exit the monitor, press the shortcut key Ctrl+ right bracket. We just did all of that with a few button clicks. But behind the scenes, a series of powerful tools are working together. Understanding them helps you gain a deeper insight into how ESP-IDF works. Here is a brief introduction to give you a preliminary idea. ESP-IDF provides a command line tool called idf.py that handles project configuration, building, flashing, and monitoring in one unified command. You don't need to juggle multiple low-level tools. Instead, you can complete the entire workflow with idf.py subcommands. In VS Code, most operations on the ESP-IDF extension status bar actually call idf.py under the hood with only a few functions directly invoking lower-level tools. Now let's walk through how idf.py runs through the entire development workflow. Creating a project, execute idf.py, create project to generate a new project framework with a standard directory structure and necessary build scripts. Configuring the project, use idf.py set target and idf.py menuconfig to configure the project. Invoking CMake and the kconfig system to complete project configuration. Building the project, run idf.py build, which calls CMake to parse the project structure and then uses build tools like Ninja or Make to perform compilation. Flashing the firmware. After building, call idf.py flash to program the firmware onto the ESP chip. Under the hood, it calls the ESP-tool.py tool to communicate with the chip and complete the flashing. Monitoring. Once the firmware is flashed and running, start the serial monitor with idf.py monitor to view logs, which relies on the ESP-IDF monitor tool underneath. Next, let's look at another classic example, Blink. This program blinks the onboard LED. With this example, we'll focus on how to modify the project's own settings using the SDK Configuration Editor. The steps to create the Blink example project are similar to before. Open the ESP-IDF extension panel. Select New Project Wizard. Find Get Started or Blink in the ESP-IDF examples, complete the settings, and create the project. The project structure of Blink is largely similar to that of Hello World, but includes additional files prefixed with SDK config.defaults. These are default configuration files for different chips. The build system automatically loads the corresponding default configuration based on the target chip you have selected. Another noteworthy file is kconfig.projbuild. It uses kconfig syntax to define project-specific configuration options, such as the type of LED and the GPIO pin used to control it. These options then appear in the configuration editor for us to set. This is a key design principle of the ESP-IDF configuration system. You pull out variable parameters into independent settings, managed centrally through the configuration editor. That way, the same source code can adapt to different hardware or requirements without being changed every time. It reduces errors and makes your code much easier to maintain. Before flashing Blink, we need to correctly configure the LED pin according to the hardware design of the development board. First, confirm that the target chip and serial port are properly set. Then, click the SDK Configuration Editor icon on the status bar to open the graphical configuration interface. On the left, find and click Example Configuration. The right side will display the configuration options defined in kconfig.projbuild. There are 3 key settings: LED type, GPIO number, and blink period. The ESP32S30 development board has an onboard WS2812 addressable RGB LED, which is connected to GPIO21. Therefore, keep blink LED type as LED strip. Change blink GPIO number to 21. Keep the blink period at its default. After making the changes, click the Save button in the upper right corner. Only then will the configuration be written to the SDK config file. SDK config is the core file in an ESP-IDF project that stores project configuration. In principle, we should not edit it manually. Instead, we should always make modifications through the configuration editor like this. If you prefer the command line, you can also open an ESP-IDF terminal. Run idf.py menuconfig to configure using the classic text-based menu interface. The effect is the same. After saving the configuration, click the Build, Flash, and Monitor button on the status bar. The ESP-IDF extension will then automatically perform the 3 steps in sequence: Build, Flash, and Monitor. Once flashing is complete, the LED on the development board will start blinking at the configured frequency. At the same time, the serial monitor will print corresponding logs indicating the LED state changes. Well, that's it for this lesson. Let's quickly recap what we covered. First, we learned about the general ESP-IDF development workflow. Then, we walked through the complete workflow for running an ESP-IDF example in VS Code. We also learned about the toolchain behind the ESP-IDF development workflow. Finally, we saw how to modify a project's specific configuration using the SDK Configuration Editor. If you encounter any issues or have suggestions as you follow along, feel free to leave a comment. If you found this video helpful, please like and subscribe to support us. In the next lesson, we will learn how to create an empty ESP-IDF project and start programming. Thank you for watching, and see you in the next lesson.